Welcome, pre-calculators. We're looking at matrices tonight, I think for the last time. Area of a triangle. Did you know we could find the area of a triangle with matrices? And we will do that on this day of 1/14/16. So sometime on Thursday, you will be observing this and jotting it down in your comp book. All right. We've already seen that you can find the area of a triangle in our past math life, 1/2 base times height, and we've also seen when we were in trig land, we could see that if we knew an angle, we could do 1/2 side AB sine angle C, or 1/2 BC sine angle A, or 1/2 AB BC AC sine angle B. So it all depends what we were given in the triangle. So one of those can work. And then there was another way, and that was Haran, and he said that the area of a triangle could be found with this mysterious value S times S minus the length of side A times S minus B times S minus C. And does anyone out there in video land remember what S meant? See if you can tell me. It is, say it a little louder. Ah, I heard you. Very good. A plus B plus C divided by 2. All right. So we need, this is not enough ways to find the area of a triangle. We need another way. So we're going to look at matrices today. And matrices will show us another way that is sometimes more convenient. And we're going to find the triangle area by knowing first its vertices. So let's say that the vertices of the triangle are known, and they are going to be, in general, the first vertice is x1, y1. That's one's a comma. X sub 1, comma, y sub 1. And x sub 2, y2, x sub 3, y sub 3. So those are the three vertices of our triangle. So let me give a quick sketch of that. Let's say that I have a triangle here, and it's on a coordinate plane, and just say it looks like that. So this could be vertex x1, y1. This could be vertex x2, y2. So we would actually know that point, and this point. And that would be x3, y3. So if we know those three, we can put those together with matrices, and the area of a triangle is plus or minus 1/2 times the determinant of x1, y1, 1, interesting, x2, y2, 1, interesting, x3, y3, 1, interesting. And remember, the straight lines mean determinant. So we always have a 3 by 3 dealing with triangles. So in the example, we'll review how to find the determinant of a 3 by 3. What's this plus or minus business here? Is it plus or is it minus? Well, it turns out area, as you might foresee, has to be positive. So if the determinant comes out to be negative, then we're going to use the negative 1/2 so that we get a negative times a negative, which will correspond to a positive area. If this comes out to be positive, then we will use the positive 1/2. So let's just try one. Say the vertices are 1, 0, 2, 2, and 4, 3. So I'll call this x1, y1. It doesn't matter which one gets what assignment as far as the 1, 2, 3. And so we have that. I'm going to sketch it just for viewing pleasure. 1 over and 0 So let's say that's 1, 2, 3, 4. And 1, 2, 3. So there's 1, 0. 2, 2. About there. Put it over here. 2, 2. And lastly, 4, 3. All right. So making a triangle out of that will look something like this. All right. I was wondering what the area is of that triangle, and I'm sure you are curious as well. So what we do is we're going to use these numbers in this matrix. So we know the area is plus or minus 1/2. We'll decide which to use in a second. And the matrix determinant will have, the determinant we need is from the matrix with a 1, 0 and a 1, always here, the interesting one. Then we'll have 2, 2, 1, and then we'll have 4, 3, 1. All right, so our job then is to find this determinant and multiply it by either 1/2 or minus 1/2. So I'm going to use cofactors because I happen to like them, minors and cofactors. So whenever there's a 0 and low numbers like 1, I usually go for it. And I think it's quicker. But you can repeat the two columns moving south and north and get it wrong. No, you'll get it right, but you have more chances to get it wrong, I think. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So we have our little checkerboard. When we use the cofactors, we pick a row or a column. I picked this row. And the 1 is the first element that will appear in the determinant. And then I will recognize that it matches the plus. So I'm going to call it plus 1. And it's going to be followed by the determinant of a minor, a lesser matrix. So this is a 3 by 3. So I'm going to ignore all the numbers in the column that the 1 is in and all the numbers in the row that the column is in. So that leaves 2, 1, 3, 1. And I'll come back and do that determinant. Now I go over to my second value in the row, and that is plus or minus, plus is, it's in the negative spot on my checkerboard, but a minus 0 has no meaning really, so it doesn't really matter what's in here because 0 times it will be 0 anyway. So I won't fool with that minor. So then I'm over here to this element, and it's in the positive position, followed by what matrix? Can you foresee it? I'm going to ignore the column and the row that this one is in, and it leaves this minor matrix, 2, 2, 4, 3. All right, to find the determinant, 2 minus 3 adds up to a -1. There's that plus 1 out front. 0 I'll ignore over here. 3 minus 8 gives me, 6 minus 8 gives me a -2 when I add those, and it has a plus 1 in front. So we end up with a -1 and a -2, which is a -3, but we have to go back and grab this 1/2. So we want our area to be positive. Since the determinant was -3, then I'm going to multiply that by -1/2. And I get positive 3/2. All right. So that's my lesson for today. If you did the determinant, or if you want to do the determinant by repeating these two columns, you may do so. So I will give you some of those to practice tomorrow. So this was a short, sweet, neat lesson. So I hope you enjoyed it. I will see you tomorrow. Bye.